Hello, my name is Amadeu, and in this video I will demonstrate my prototype and implementation of the Chainlight ability for the Epic Games test. I will show how it works in gameplay, break down the technical aspects, and explain how each design decision aligns with the given requirements. So a few quick words just to explain what I did here before activating the ability. I used the starter content for this prototype. I used the third person template, and this bunch of cylinders represents the enemies for the chain ability. Here I activate the ability and the chain light is fired towards the direction the player is facing. If a valid target is hit, the ability applies damage and begins the chain reaction, as you can see it. The lighting automatically seeks the next target available within 10 meters. This process continues until either no more valid targets are found or the ability reaches the maximum of 30 bounces. Each bounce occurs with a short delay, adding clarity to the effect. As you can see it, I used a draw debug sphere for representing the chain light. The yellow one here is the first hit, and the dark blue are the bounces of the first wave, and the light blue are the second wave chain light. Now let's see how it behaves when there are fewer than 30 targets available. Activate and then as expected, the ability stops chaining once there are no valid targets left. And the ability has a cooldown of 5 seconds, ensure that it cannot be spammed repeatedly. If I press play here and press my hit key and then I hit, I try to do it again, pressing E, and activated cooldown appears as you can see it. And no repeating targets. A check is in place to prevent the ability for hitting the target twice in the same chain. Now let's go through the blueprint implementation step by step. Using 3 blueprints for the Chainlight ability provides clear separation of the responsibilities, making the system more modular, organized, and easier to debug. I used the BP third person, the BP sparks, and the BP enemy cylinders, each one with a reason. The BP third person character handles the core logic of the ability, including activation, target detection, damage application, and the cooldown management. For the enemy cylinder, it manages enemy behavior, handling damage reception and destruction when the health reaches zero. And for last, the BP Sparks, dedicated to the visual effects, ensuring impact feedback without interfering with the game logic. So this separation in 3 blueprints brings advantage for this approach. For example, modularity, so each blueprint has a specific purpose, make adjustments and reuse easier. Better performance, separating visual effects from gameplay logic prevents unnecessary processing load. And for last, easier debugging. Errors can be traced and fixed individually without disrupting the overall functionality. Now let's go through each one of the BPs, following the logic. This one here is the BP enemy cylinder, this guy here that represents the enemy for the prototype. And you can see that I use a variable health for its life, it's a float. And we have here an event any damage. So when damage is received, we set the damage here and we subtract health minus damage for the and set the health. And if it's equal or below 0 and it's true, then it will be destroyed. But before that, we have a delay of 8 seconds, and then we valid if this guy here exists to prevent errors. It's a good practice to use isValid to determine if that actor or some other component is still valid before doing the destruction, for example, or other cases. The 8 seconds before destroying actors allows enemies to disappear first, while the chain light effect lingers on the ground and enhances visual impact, reinforcing the power and the aftermath of the ability. The next one is the BP Sparks. Here we call the BP Sparks in the world, and then when he is called, we have 8 seconds delay, and then he is destroyed. And finally, let's go to the BP third person character where the main things happen. We have 4 events. The first one is the enhanced input action EA chain lighting that activate the ability. We have the reset cooldown, and we have the storage bounces and the make chain light bounces. And I will explain this one here first. So in the BP third person character, before explaining this, we have some variables. As you can see here, we have the remaining bounces, an integer, to show how many bounces are left. We have the cooldown active, that is a boolean. If it's true, then the cooldown is activated and the player can't spam the ability. We have a set of actors, that is the target's hit, so it's the list of characters that are hit, so the player cannot hit again. We have the max bounces, there is an integer, so we set in the value of 30. So, because it's the max. And we have this variable here, the bounce delay. There is a float that we control the delay of the bounce. And we have this variable here, there is an array of actors. So we can control better the depending actors that still have to bounce the ability. So let's go then. This event here, it triggers when the player presses E. I have set here, as you can see, AI chain light, keyboard E. This is the AI chain lighting. And when the player presses E, we have this phase here to set the remaining bounces as 30. Here, 30. We set the remaining bounces. And we have a clear phase, so the player can use the ability again. This is very important, the clear phase. And then we check if the cooldown is active. It's active, I print string activated cooldown, otherwise the ability starts. The ability uses, as you can see it in the video, sphere trace by channel. That for the final implementation we can put none here so we can't see it. But this sphere is traced, getting the actor location, in this case the third person, and then we put a forward vector of 1000, and we add this to the actor location, so we get the actor location, and then plus a forward vector, and we will have a sphere trace. There is like a linear one. And this is the node to detect the BP cylinder, the enemy. And when it's detected, we can show here the hit, and we get this hit actor, and we validate if he's valid. If he's valid, we storage here in the target hit. And then I was using this for debug so you guys could see the chain light colors, which ones are the first wave, which ones are the bouncing, but I turn it off here. And I put, so next we use the spawn actor BP sparks, so the effect of the sparks appears on the level. And then we go to this. We call this event storage bounces, and we set the remaining bounces here. We pass the remaining bounces for this event. I'll go there, but just continue here. Then because the player pressed the E and we hit the target, then the cooldown is active, and we will have to wait for 5 seconds here. The set timer by function, and the function is reset cooldown, as you can see it here, that after 5 seconds the cooldown is false, and then the player can press E again, and then he will go to there, this branch here, and he will be able to uh, spawn the ability again, press the ability again, I mean. So let's continue here. When we call storage bounces, he receives the current target, in this case the primary target, the one that was hit by the player when he activated the ability, and we pass the remaining bounces that we know that is 30 initially. And then the storage bounces are called. We pass the primary target and we pass the remaining bounces. He checks if remaining bounces are greater than 0. If it's true, okay, then we get the target location of that primary target, and we use the multi-sphere trace by channel to detect the other BP cylinders or enemies that are around that primary targets, and that's why we have a radius of 1000 Unreal units that represents 10 meters. And we get all those guys here in this array, and then we check if it's a hit. If they are in 1000, it's a hit. And we set damage, then we print string the damage, and then we check here if targets contains. If it's not contains, it's false, then we add the pending bounces. If it's already contains, that means it was already hit. And then we proceed to make chain light bounce. And then the event make chain lightning bounces is called. It passes through a flip-flop, and we have the pending bounces storage here. So we get those guys one by one, and we check if it contains targets hit. If it's false, we add the targets hit here, and we set in, and then we spawn the BP sparks in each one of them, and we set the remaining bounces again, following that the pending bounces, the length of them, the remaining bounces minus the length of them in a value that is 0 to 30, and we have the remaining bounces and set here. If it's true, if it's contained, okay, he will not repeat this process. And we have a flip-flop here in B. We get the pending bounces. We use the bounce delay. We get those actors here, and we spawn the multi-sphere trace by channel. This is for the second wave of bouncing. We get those guys here, and then we check if it's contained, the pending bounces. If it's false, we add and we set, and we spawn the BP sparks for them. We get the hit here, and we display got hit from the second wave bounce for debug purpose. I'm not using this. We check the valid, we apply the mesh for the second wave, and we print that those guys took 100 damage. And he goes A and B, A and B. So the reason for the flip-flop in my logic here, in my chain lightning logic, is that creates variation in bouncing partners, avoiding predictable enemy targets, helps distribute the effect more dynamically. So by implementing flip-flop, avoids a linear, repetitive chain action and creates a more organic, is the main word here, organic and visually diverse effect. And that concludes my submission for the chain light ability. Thank you for your time, and I look forward to any feedback.